Hello everyone, good evening. Dear authors and invited guests, welcome to Technical Session 9D. Myself Sirali Gaur and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD 2026, Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today, 10th of July 2026, Goa, India, and the virtual event is being held through Zoom from 9 to 11 July 2026. I hope you will enjoy this knowledgeable and interactive session through the day. In this session, we have a total of 10 presentations. Each presenter will be given 10 minutes for their presentations and 2 minutes for question and answers. On the 9-minute mark, I will raise a gentle reminder. There's another request to all the participants that you stay connected with us till the closing remarks. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Sopan A. Talekar. Dr. Sopan is currently working as an associate professor, dean, and head of department IT at Karamveer Baburao Ganpatrao Thakedar College of Engineering, Nashik, India. With over 21 years of academic experience, he has published and presented more than 10 research papers in reputed journals and conferences. His areas of specialization include cognitive radio networks and bandwidth estimation in wireless networks. Welcome, sir, and please share some words with us before we start with our presentations.
Yes, thank you, ma'am.
Okay, so let's begin with our presentations. Our first presenter today is Kanak Gule with the paper title A Hybrid IoT Generative AI Framework for Explainable Remote Patient Monitoring and Clinical Decision Support. Dear presenter, you may start presenting.
I hope my screen is visible.
Yes, ma'am.
Okay. So good afternoon, everyone. I am presenting our work on the AI digital nurse, a hybrid IoT and generative AI framework for remote patient monitoring. So the core idea is simple. It's the that just don't detect when a patient's vitals go wrong. Explain why in language a nurse can act on immediately. So, moving to the problem statement, existing remote monitoring systems have four recurring problems. First, alarm fatigue, fixed thresholds fire constantly, so clinicians start tuning them out. Second, black box AI predictions, anomaly models flag something wrong without saying what or why. Third, lack of interoperability or poor responsibility between sensors and dashboards. Add fourth, no sense of urgency. A nurse gets a number or a red flag, not context on how serious it is. So our system is built to address all these four problems. So our solution is a three-part pipeline. An ESP32 based sensor node continuously captures heart rate, SpO2, temperature, IV fluid level, and motion data. A personalized machine learning model trained per patient detects when something is genuinely abnormal for that person. And when it flags an anomaly, Gemini generates a short, plain language clinical explanation before it ever reaches the nurse dashboard. So our system architecture is mainly divided into three parts. So the first layer is perception layer. Um, the perception layer consists of nodes and sensors at the bedside. The intelligent layer lives in the Firebase. It runs the personalized anomaly model. and only when that model flags a reading does it call Gemini for clinical explanation. The application layer is the React dashboard with role-based views for nurses, doctors, and family members. So these are the modular hardware and software features which our platform contains. So first is we have used very low cost sensors which monitor all the patient vitals. Secondly, we have real time anomaly detection. We have trained model for each individual patients based on their individual vitals instead of just setting thresholds or general medical thresholds for each and every patient. So next is generative clinical summaries. Our Gemini 2.5 Flash converts raw abnormal readings into a very easy language English explanation, which can be understood by the patients as well as the doctors or nurses very easily without any complications. Then next we have serverless cloud core. That is, our all the data is saved on the Firebase cloud, so we can easily track the patient's history and train the model for future as well. Then next we have centralized dashboard, which shows all the patient vitals and also the explanation given by our Gemini Flash. And lastly, we have again the explainability, which most of the uh, AI systems or the RPM systems lack. So, this is the part I want to highlight because it's the core novelty of our anomaly detection. Instead of one fixed threshold for every patient, we collect a calibration period of baseline readings for each individual patient, as I told before, and we train a dedicated isolation forest model on their normal range. So the model is stored in Firebase cloud storage under that patient's ID, and every new reading is scored against their own baseline and not a generic population threshold. So what counts as abnormal is different for a 25-year-old athlete versus a 70-year-old post-OP patient, exactly as it could be in practice. And this in as we can see on the screen, a bounded prompting for safe explainable AI. So Gemini is never a standalone diagnostic engine. It's only invoked after the isolation forest model has already flagged an anomaly. We prompt it to act as a nursing assistant and not a doctor. It gets structured, validated vitals only. And its output is deliberately constrained to one or two sentences. So, suggestions, actions are provided, and it never provides a final diagnosis. So, we have also secured that Gemini will not give any wrong assumptions or wrong diagnosis. So, these are the few differences which are present in our project. Multi-vital fusion. So we have integrated all the five major vitals, uh, which are not generally integrated in the RPM systems. Second is the anomaly explanation. In anomaly explanation, again, as I said, the explanation is given in plain language summary instead of black box label or no explanation. In clinical alarm context, we have urgency plus reasoning, means we first prioritize the people who need immediate medical help or who are facing a emergency condition, instead of just flagging and randomly arranging the patients without the priority order. So next is the hallucination control. We have bounded and validated the Gemini prompts as well, as I discussed before, and end users role. So here we have created dashboard for various roles. We have a dashboard for nurses, we have a dashboard for doctor, and we have the dashboard for family as well. So this is the real-time dashboard and anomaly alerting of our project. So here we can see a patient's dashboard, the heart rate, everything is seen, and the status is normal. So there is no explanation over here. And here are some of our readings which are measured, and we store them in Firebase Cloud. And we also plot the graphs as you can see on the dashboard. So, lastly, we have latency and future roadmap. Across 50 trials, sensor to dashboard transmission averaged 1.2 seconds. Gemini's summary generation averaged 2.5 seconds for a total pipeline latency under 4 seconds. So, well, within range for non-ICU monitoring. Going forward, we want to scale to larger patient data sets, explore federated learning for privacy, and run real clinical trials. So, in short, the AI digital nurse turns raw vitals into personalized, explainable information, actionable insights, reducing alarm fatigue without sacrificing trust. So, thank you.
Yes,
Thank
Kanak, can you show your result slide?
This one.
Yeah. Okay, so you have used the data set. So you have used the standard data set, or you have collected the data set from different
Uh,
clinical institutes.
we have not collected a data set. We first of all we gather the data or vital data of a patient, and then we train the model for that particular patient on his or her vital data. That's our
So,
exact novelty.
okay, what would be the size of your data set? What was
Size
the
of our
size?
data, we actually trained. Cannot tell the actual size, but we actually collect the patient vitals for 2 to 2.5 hours, and then we have trained the model for
Uh,
this particular implementation.
Okay.
And in future, whenever as the patient condition keeps on improving, we again fed the new data to the model, and then the model captures the new improved conditions of the vitals, and then the model functions on that particular data.
So approximately how many patient data that you have collected for training the model?
For training the model, we have collected 5 to 10 patients data.
Only. So in that actually you actually don't uh, observe the problem like overfitting or underfitting.
No, actually, it was not a problem for those patients.
Then my last question is that so your framework does address the that the privacy, security, scalability, or regulatory compliance.
Yes, it addresses as we have stored the data on cloud Firebase. So Firebase takes care of all that security part. It has proper authentication. It has provided proper authentication for, as I told, there are user-based dashboards. So that authentication is provided to all the nurses, family members, and doctors.
Okay, ठीक है. Thank you.
Thank you.
Thank you so much. Next, we have Namoha Panchal with the paper title A Hybrid Web Crawling and Semantic Information Retrieval System Using Transformer Based Embeddings. Dear presenter, you may start presenting. Okay, next we have Varat Charolikar with the paper title A Systematic Literature Review on AI Driven Career Readiness Systems, RAG Multi Agent Architectures, Mock Interviews, and Resume Intelligence.
Yeah. Hello. Just a minute. I'm just starting my screen share.
Yeah,
Is my screen visible?
but not yet.
Oh, just a minute. Is my screen visible now?
Yes.
Okay. So I'll just start with a small observation that we had during the research. So by the time we have finished reading a single job posting, AI has already decided whether 46% of the skills in it are even worth a human anymore. And that's not a prediction. That's from the Indeed Hiring Labs 2025 report. And here's something we found that surprised us. Across our exploration on AI career readiness systems, spanning resumes, mock interviews, AI coaches, not a single one tracked a candidate all the way to an actual job offer. Hello, my name is Varat Sarholikar. The paper ID is 1252, and the title of our paper is A Systematic Literature Review on AI driven career readiness systems using RAG, multi agent architectures, mock interviews, and resume intelligence. I'm sharing this paper with my co-authors, Manas Jain, Isha Katkar, Vishwa Patil, and Madhuri Bhalekar from MIT World Peace University, Pune. Over the next 8 minutes, I'll show you that how we got to the finding and a framework we are proposing to fix it. Okay, so let's start with why this matters. The Stanford AI Index reports that 78% of organizations now use AI in at least one of their business functions. At the same time, the Indeed Hiring Lab found that 46% of the job posting skills are already overlapped with what AI tools can do, and this creates a problem. The junior roles are shrinking inside the overlap, and we define that widening gap as the career information gap. Students and the early career candidates are being asked to compete in a market that's changing faster than the guidance available to them. We structured this review around three questions. What architectural components categorize these systems between the papers of 2020 and 2026? How integrating RAG with multi-agent systems improves factual accuracy? And what evaluation metrics and ethical safeguards appear? To answer them, we followed the Prisma 2022 methodology, checklist of 27 items, and searching across Scopus, Web of Science, IEEE Explore, and ACM Digital Library. After going through a lot of research papers, we sorted the types or categories into four functional things. We call it a hybrid expert AI umbrella. So this umbrella shadows career co-pilots, assistants, that those are the resume tools or the resume creation tools, conversational AI for interviews, and recommendation systems. Together, these make up what we are calling career AI systems as a field. And this taxonomy is what let us compare very different papers on the same term. It's worth seeing how we got here. Between 2010 to 2016, we were using traditional ML systems like random forest, TF-IDF, to match resumes to jobs. From 2016 to 2022,
Dear presenter, you're on mute.
am I audible?
Yes.
Yeah, sorry for the disturbance. So I was talking about since 2022, the field has moved to generative AI and agentic AIs using LLMs, RAG, that is retrieval augmented generation, and MAS, that is multi-agent systems, which is where our review sits and the framework that we provide sits. So now let's talk about some metrics. So from all the papers that we studied, the systems that are currently in place acting as career guiders or career advisors, 58% of the systems use RAG, that is retrieval augmented generation. 43% use multi-agent systems, And when RAG is embedded inside a multi-agent pipeline, hallucination rates drop significantly, right from 15% to 1.45% in the best performing system, like the best case scenario. Now, I would like to let you know about two main core systems that we studied. One is Meros. So it is a multi-agent and retrieval augmented university admission systems, and it is a admission systems used in Vietnam for counseling across higher education aspirants. And it combines multi-agents, orchestration, hybrid semantic retrieval, and LLMs. This provides precise, low latency, and hallucination free services. Now, the second one is Common. It is called as Collaborative Multi Agent Framework or Intelligence. So, this framework is majorly to give scorings to the AI interviews, and this framework is not personalizable. It is very static, the Komai framework. But the one thing is that it does not give up on the bias resistance. It is more bias resistant. And on the basis of this, we plotted a plotted representative systems on two axes. On the x-axis, we have the system complexity, and on the y-axis, we have the level of personalization. So as we can see that Meros is highly personalizable, but the problem is that it does not maintain memory, or it does not maintain the states. Uh, Komai does it, but then it is not personalizable. There was one more platform, that is Resume Flow. It adapts to a specific job posting, but also resets every session. So it is also not maintaining a state or memory. So nothing in our corpus occupies the high complexity and high personalization quadrant on the right hand side. So that gap is exactly where we are positioning our framework, that is called as ACOF. So ACOF stands for Agentic Career Orchestration Framework. It is a modular 5 layer pipeline. So a user interacts with the interaction layer, that is the UI for the platform. Then that interaction is fed to the conversational AI layer. This conversational AI layer is grounded by a RAG layer pulling from a live vector database where the embeddings are stored. And below that sits the multi-agent layer, that is the core part of the ACOF framework. This multi-agent framework would consist of the interview agent, resume agent, feedback agent, and career agent. And all of these would be sharing the data between them and performing individual tasks. And their outputs are aggregated into the analytics. What makes this different from prior systems isn't a single layer. It's that these agents actually, share the state, and I'll show you how they do that. So as you can see on the left hand side, we have the existing systems. Uh, there are resume agents, interview agents, feedback agents, but the problem is that there is no data sharing between them. All the data is siloed. A past resume never informs what interview questions get asked. So even though the data is sitting there, it is of no use. ACOF fixes this with something we call the vectorized competency map. So it is like a graph structure consisting of all the data of a particular individual, right from maybe, let's say, his achievements in his school, then his 10th grade marks, his 12th grade marks, his stream, like like the quantifiable data and the and the hard data or the qualifiable data. Uh, and this vectorized competency map is like updated after every session, and hence all the agents can read the data and write to it. It's a small architectural change with a big implication. The system remembers you and gets sharper over time instead of starting from zero for every session. From all of this evidence, we distill six design principles: ground outputs in retrieved evidence, then use dedicated agents, not monoliths. We don't need a one fits for all solution. We can use various agents for various functionalities. The fairness should be built in, not just bolted. Then track careers longitudinally. Right now, what the current systems do is that they only test the user for the current assessment, for the current scenario. But it should not be the case. The person should be tracked right from his childhood to what he is right now. Consent by design for sensitive data, and no global claims without multilingual validation. And underneath all of this, there sits the field's biggest blind spot. A, ne- a candidate is never tracked all the way to an actual job interview. Every reported accuracy number in this space is still a proxy. And so RAG, mass architectures are already delivering measurable gains. But the field's methodology needs to catch up through career digital twins, human in the loop copilots, federated learning to protect privacy, and most importantly, longitudinal studies that follow real hiring outcomes. So, trusting in these and getting ACOF into action is where we can shape the future of AI. Thank you, and I end my presentation here.
Hello.
Hello. Yeah.
Yes. Yeah, it was nice presentation and literature you have done. Uh, can you show the how many the papers that were referred for this work? How
Uh,
many
s-
references? Yeah.
so basically, the metric is not here in the presentation right now, but we referred around 287 papers, and from those 287 papers, we finalized 69 papers, which we used in this study.
Okay. So you gone through all those 287 papers?
Yes, sir.
Okay. So what different AI tools that were used to read to extract that paper, extract the information from that papers?
So basically, what we were trying to do is that we tried using multiple AI tools in the market. We had also built a custom scraper for it to get a few information, and using that scraper, we got the information and we validated it against the existing AI tools like Claude and ChatGPT. And finally, we extracted the data from all the 287 papers, and then we found some duplications. We removed those duplications. Then we found some, repetitive overlapping content, not repetitive, but some overlapping content. We removed that, and finally, we had the 69 papers in our hand.
Okay.
Yeah,
Then from this survey, obviously you have observed some evaluation metrics from different papers, right?
yeah.
Uh, so for those evaluation metrics and fairness measures, uh, how do you recommend for addressing these systems? What different evaluation metrics should be there to evaluate or to assess the system?
So basically, as I just said, that all the systems are very siloed.
Hmm.
They only focus on that particular assessment. But what me and my team thought of is we should consider the evaluation right from the very beginning. So, for example, if a person is sitting in front of of the system and he's given a AI mock interview, so if he has X number of marks in his earlier evaluation and he has some XYZ feedback in his earlier evaluation, that evaluation and the current evaluation should be considered. It should be combined, and then the final evaluation should be given. So we are proposing that the data should not be siloed. It should pass from each and every evaluation or each and every session that the user is having with the system.
Okay.
In fact, sir, I would just like to add one point. We are ourselves trying to build such a system. We have two modules. We have built two modules. One is resume creation and optimization, and the second is AI mock interviews. And right now, we have connected the two modules. So what is happening is that the person would first create a resume, then he would optimize the resume based on the jobs that are available in the market, so that there is a bit of a manual work which we want to automate. That's the space that we are working on right now. And after the resume is completely built, that resume is used to ask questions in the interview. So it is not like the questions in the interview are completely different from what the person is actually working on. So we are trying to establish a link there to evaluate the person.
Okay, okay, thank you, Varad, and say hi to Bhalikar ma'am, who was my
Yes,
ex-colleague.
sure,
Okay,
sure.
yeah, thank you.
Thank you.
Thank you so much for that presentation. Next, we have Komal Borisagar with the paper title A Tiny ML Enabled Federated Graph Reinforcement Learning Framework for Energy Aware Intelligent Optimization in Edge 6G Networks. Dear
Yes,
presenter,
madam. Ma'am,
yes,
hello, madam. Am I audible?
yes, ma'am.
Yes, you
Ma'am,
are
I'm not.
audible. Yes, yes, you are audible, and all the participants are requested kindly adhere the time limit. Time constraint is there. Okay, so you finish within the time so that we can cover up all the participants within the time.
Yes, sir.
Hmm.
So I am sharing my presentation.
Yes, ma'am.
Ma'am, is it visible?
Yes, ma'am.
Okay. So should I start now?
Yes, ma'am.
Okay. So good afternoon, one and all present over here. My name is Dr. Komal Boris Sagar, and on behalf of my co-author, Dr. Anand Rawar, I am presenting my paper with the ID 1654, a tiny ML enabled federated graph reinforcement learning framework for energy aware intelligent optimization in 860 network. Both of us are from the Gujarat Technological University, Ahmedabad, India. In this next few minutes, I would like to share my thoughts and what we have done on the database, that how the networks are working and what is the role of AI to get the latency and throughput and everything up to the mark. So we have done a small experiments and we have get some good satisfactory result. So we will talk on that. So now I am starting with my presentation. So first of all, that we know that we are continuously thinking about how generations are working. How can we roll out with the 5G and now it's a 6G, right? So has driven and continuously rise in the connected devices, more and more traffic volumes and service quality, except expectations, and what people are demanding, that they have a more and more expectation from the working of the network and network layer, and as far as speed is concerned, always demand is high. So in this modern age network, one network must simultaneously deliver four things, and which is the most importantly into the demand, that is the ultra low latency, high throughput, energy efficiency, because each and every node, each and every device is a battery backup, and intelligent along with the adaptive resource management at the RF level. Now the difficulty is that the conventional optimization methods, the classical control theoretical approach, they are continuously changing on a different parameter for making a decision. So it is not designed for the environment, that are this dynamicity that must be adapted onto the large scale and at a heterogeneous level. So they tend to break down the precisely where exactly problem is there, and from that point we need to start our work. Okay, we have a 6G and edge computing network that can be give us some kind of solution to that. So that gap is the starting from our work. So that is the most important part. So mainly research gap that we need to point out over here very sharply and precisely, that we can divide that into the three different parts. So first, there is a lack of adaptive real-time decision making under the dynamic network condition, and no existing mechanism right now present to get a what we can say dynamic position and spatial position of the nodes among the network. In other words, most important method treat nodes independently rather than a connected system, because each and every node has a very precise role to form any of the networks, so that someone should understand. Second, resource constrained edge devices needs lightweight on-device intelligence, and yet current approaches still include high communication overhead and high energy consumption. So as far as our that generation and cellular transmission is concerned, we are taking a more and more number of hops. So because of that, more and more number of overhead bits are there, and again they are increasing the usage of the bandwidth, and because of that, latency will be increased. So that is always a trade-off. Okay, how to route our packet, and along with how to get the throughput. Third and most importantly, there is a no unified framework that brings prediction, network aware reasoning, and decentralized decision making together under the architecture of the real-time optimization. So these three are the mainly basically our research gap, and that we need to address over here. So now it's a problem formulation such a way that we model the age 6G network as a graph, and which is a function of V and E. So mainly that V can be considered as a nodes, and that they are the edge devices, matlab base station, or we can consider that as some agent with whom we are going to work. And edges, they are considered as a communication link, and they are providing the connectivity and communication between the various nodes. On the top of this, we introduce a two level of intelligence. The tiny ML layer operates locally onto the each of the device that we are considered as our that nodes, and they are performing traffic prediction, data filtering, anomaly detection, and energy estimation, all without sending the raw data anywhere. So all the processes will be in-house. The graph over multi-agent reinforcement learning layer sits above it, and model take the dependency, and between nodes across the network, they are performing the decentralized source observation, and after that it will give the optimization of the resources, which is very important to manage the traffic. And if traffic is managed, then latency has a great effect on that. Binding this two layer together in a federated learning, which aggregates model updates across the devices while keeping raw data local, which is essential for the both privacy and communication efficiency. So by this way, we try to train our model, and accordingly we had tried to get our data. After that, we can summarize by this way that optimized workflow proceed in a 4 stage. Tiny ML pre-processes local traffic data, a graph, neural network capture, network-wide spatial relationship. After that, most important, that is a MARL, selection optimal resources allocation in the routing actions and algorithm. After that, we have federated learning synchronization global model. And the key constraint, what we are going to address are bandwidth limitation, energy budget of edge devices, low latency requirement, reduced communication overhead, the privacy preservation along with the security. So here we have put one conceptualization related to our equation, that is optimization objective is what? So minimum latency plus energy consumption plus communication overhead, and what is the maximally required on which we have focus, that is a QoS and throughput. So after that, we have defined the function like this way. Okay, we need to increase the quality of service, then throughput. Along with that, increase in the throughput, we need to require low latency, low energy consumption, and low communication cost. So by this way, we had tried to work in the system. So most important that what methodology we have adopted. So we have proposed that is as per the our thought and our something based on the literature survey by the observing of a different paper. So we have kept one thought in our mind, that is a proposed age mind tiny GRL framework. So now what is actually this one? So we have taken hierarchical distribution architecture in which the things that is in our mind for the core distribution are that we have taken age, that is most important, the network sits at the edges. Then we have considered here intelligence, so that is our mind. So that is a one abbreviation we have taken. Whatever the OS running, that is a tiny ML, tiny LSTM, the lightweight on device on the prediction layer. Then G stands for here GRL. So here G stands for the GNN, that models spatial topological relationship between the nodes, because as we know that all the nodes are randomly located and they are continuously changing their location, and because of that fading and everything is there, so that we need to consider Doppler effect and fading everything. So accordingly some low sweep is there into the received signal power, that is known as RSSI. After that we have worked on the reinforcement learning. So that layer is for the decentralized decision making, and after all making all the throughput up to the level. After that we have a learning mechanism. So learning is going to compass both RL and federated learning aggregation. So by this way, by collaborating all this way all together, we can try to improve something into the output, and whatever the result that we can improve at the some extent. So end-to-end workflow is a straightforward to state. Row traffic data flows through the tiny LSTM into the GNN into the MIRL, and finally decision making, and then through the federated learning producing a optimized 860 network. So now moving towards again methodology.
Dear
So we have
presenter, I'm
yes.
sorry to interrupt, but you have crossed the 9 mark limit. Please conclude your presentation soon.
So these all are the methodology. Now this is my framework by which we have taken a different layer. So this is a age network, tiny ML, then this is a graphical representation, then agent requirement, and then we have this is a flow. After that these all are the results in which we have taken, if we are taking LSTM, then this is the throughput, RL, then this is the level of the latency and throughput, and then we have used the tiny ML, then we can see the improvement. This is the most important result is that if we are not optimizing and we are not using our algorithm, then the traffic is randomly distributed. But if we are going from the different algorithms, then we are able to manage the traffic and we are able to balance the load by this way. Again, we have a federated learning. So by this level, we are able to reduce the communication cost. Communication cost includes throughput, latency, and that energy. So that they are part included into the cost. So these four are the different combinations. So by this way, we are able to manage the traffic by taking a different combination. Then we have created a heat map also, that along with the different algorithm, then how much iterations are there, and what is the energy of the node has been optimized. If this many tiny ML in a OS, some iterations are going to run and decision is going to be done. So this is the comparison of that. And again, this is a LSTM, GNN, RL. So we have taken a finally, this is our proposed algorithm. So by this way, we are able to lower the latency, and we are able to take our whatever we have taken into the consideration, that we are able to achieve. And for that, we have used some very practical and real-time database. So based on that, it is crowded database. So based on that, we have taken all these results and we had tried to achieve our goal. Thank you, ma'am.
Okay. Okay, madam, you just show me your results.
Yes, sir.
Show me your results. Results slide. Okay. The next one, the previous one. Previous one. Yeah. So here, you have compared the results, right? With different metrics like MAC, latency, throughput, and energy, right?
Yes, sir. So, sir, here we have taken a different algorithms and different combination.
Yeah, I
And
got it.
based,
I got it. Just let me know how this whether this simulation is done using what tools that were used to for the simulation. What
yes,
tools
sir.
that, yeah. How actually you implemented it?
Yes, sir. We have taken this database. Then we have created one agent. We have trained our model. We have taken a transform and we have fed all this data and we have taken that individual algorithm while taking the output, sir.
I just want to ask you, you implemented using any network simulator or in Python itself?
In Python itself. And also we are going to implement that on a NetSim. These results are from the Python implementation. But I have not put that result into this presentation. But by taking a few number of nodes, we have we tried to, because here number of nodes we can take at a very high level. But in NS nodes are less.
Then how did you consider the dynamic traffic when you want the results in the dynamic traffic, right? So we how actually you consider that traffic dynamic?
Yes, sir. So in our database, so we have a different chunks are there. So based on that, we can change the we are able to generate a dynamic traffic based on the throughput. Suppose we have a number of links that we have configured. So in that link from node X to Y, we are changing the transfer of the packet in form of a delayed one and in form of in a bursty manner. So by that way we have changed the traffic randomly. So that again we have added some function, random function in that. So randomly they are changing the traffic of the nodes from X to Y. So by that way again that also done through the functions only. So by some functions, random function and all that, we have changed the traffic.
Then what the parameters that were considered for the 6G environments, right? Initially you have created 6G environment, no?
Yes,
So
sir.
what parameters of 6G environment that were considered?
So in this one, we have created some layer-wise parameter while we are transferring the traffic. Say for example, we have taken some channels. Then for that channel, we have taken some of the noise level. After that noise level, we have taken some delay. Then we have taken all the parameters of the wireless communication like X to Y transmission is there, then noise heading is there, then fading is there, then Doppler effect is there, then relative speed of the nodes will be there. So all that parameter which is used in the wireless channel estimation, that we have taken as a work on the parameter. So by this way we have created a wireless channels.
Okay, thank you, madam.
Oh, okay, thank you.
Thank you so much. Next, we have Anas Khokar with the paper title An End-to-End Autonomous Threat Detection and Response Framework Using Fused CNN plus LSTM and Deep Q Networks. Dear presenter, you may start presenting.
Yes. Is my screen visible?
Yes, sir.
Okay, good afternoon. My project is an end-to-end autonomous threat detection and response framework using full CNN plus LSTM and deep neural networks. So I will like my co-author, my Professor Dr. Vijay Ukani, to introduce this project at first. Are you available, sir?
Yes.
Vijay, sir, are you there? Okay, no problem. I will deliver this. Modern enterprise networks, they generate millions of networks every hour, and they generate millions of traffic. So like intrusion system generates thousands of security alerts per day. So it's impossible for security analysts and SOC analysts to manually investigate those alerts. So like because of this huge alert, analysts experience alert fatigue. They can't go through all alerts together. So where important attacks may be overlooked among those alerts. As a result, like many attack goes undetected. Then the traditional intruder system, they mainly rely on predefect attack signatures, so that unknown attacks remains undetected. So like if there is a 0-day attack happens, then like traditional intrusion detection system can't detect those attacks because it is like different patterns from predefined rules based. So that we developed like an artificial intelligence and adaptive cyber threat detection. The problem I have explained, like existing IDs detect only known attack signatures, and they are unable to identify 0-day, like newer attack they can't identify. And evolving cyber attacks use AI in their system. So like the previous signature-based detection is not that much useful. And the second, our limitation was that security alerts. The large number of security alerts leads to alert fatigue. So manual investigation is very slow and difficult to scale. This results in delayed response and increases the impact of cyber attacks. So our motivation, a recent study by Dhanush Kodi and Tejas reported that security analysts like they have 45 days investing a single intrusion because they had to manually examine nearly 56,000 IP addresses, highlighting the need for intelligence automation. The dataset which we use is CICIDS 2017 dataset, which is like most popular for network intrusion detection system. And like network features are 49, and there are 11 different attack categories like DOS attack, spot scan attack, and labels like normal, and 10 categories. This is our proposed framework. Um, so like first network traffic like in the data set, and then we will pre-process that data set, and they will apply the deep learning model, which is used mainly for detection. And after the detection happens, we will use the AI like reinforcement learning to automatically respond to that detection and take action. So let's understand this. Our first model, CNN. The primary role of CNN was not to detect attacks. His main responsibility to extract meaningful features from the network data. In our data set, there consists 49 features such as packet size, packet rate, destination port, etc. These are the raw input given to the CNN. Inside CNN, multiple filters are applied. During training, the CNN makes prediction, compare them with the actual labels, and updates the filter weights using break propagation. This is how the training in a CNN happens. And then after multiple epochs, it automatically learns useful patterns. Then after that, all extracted tokens, the max pooling layer, the other layer in CNN, gives only the strongest and informative features, while it reduces the redundant information and noise. The output after max pooling is a compact feature representation, also called a feature vector. Instead of that 49 row features, the learned CNN patterns is transferred to LSTM. And there our next proposed model is LSTM. So we used LSTM because of temporal dependencies in network traffic. It is useful in sequential attacks like CNN can detect only attacks. It does not have memory. And then like LSTM has memory, so it remembers the past row. While the CNN extracts only meaningful features, the LSTM analyzes how these features evolve over time. The main advantage of LSTM is can remember from previous network connection. Like for example, during a port scan attack, an attacker may attempt to connect to many different destination ports. Each individual connection may appear normal, but with the help of LSTM, it views separately. The LSTM observes like sequence of this connection. So that's why we use CNN and LSTM both together. We have fused that architecture CNN plus LSTM. CNN possesses each connection 49 features. Its main is to extract local patterns and then gives to LSTM, and then LSTM receives CNN learned features and remembers previous connection, and they finally detect that attack. And then after detection, our main goal is to automatically respond that autonomous response how we can provide. So is the deep neural network, which is a reinforcement learning algorithm. For that, we have developed an custom environment called CyberHunt environment. This environment simulates different cyber attack scenarios and provides the current network state to DQN agent. The DQN is responsible. The agent in the DQN is responsible for making decisions. There is a state in DQN which represents the current condition of the network after attack resection, such as detected attack type and network status. And there are four actions we have: give, block, alert, investigate, or ignore, based on the real SOC analyst scenarios. After selecting the action, the CyberHunt environment checks whether that action is appropriate. If the action is correct, the agent receives a positive reward. If the action is incorrect, it receives a penalty reward. Like unlike traditional ID that only detect attacks, the DQN agent automatically select optimal response to detect cyber threat. How we implemented DQN agent? We implement DQN agent using CyberHunt environment. We developed CyberHunt environment as a custom gymnasium environment to simulate attack scenarios for reinforcement learning. The first step was to define the environment. Then we defined the observation space, action space, reverse function, and the interaction logic. Whenever the DQN agent selects an action, the environment evaluates whether the action is appropriate for the current state. If the action is correct, the environment returns a positive reward. Otherwise, it returns a penalty reward. Along with the reward, it also provides the next network state. This is how the interaction continues for multiple training episodes, allowing DQN agent to learn an optimal response and give better autonomous response, either to block, either to investigate, or either. This is our experimental result, which was the accuracy, precision, recall, F1 score, and which CNN plus LSTM is for detection, and DQN agent is for autonomous response. It shows the block rate 97.4%, false positive rate, and response time is less than 1 second, which is great in this autonomous decision. We have compared with a few previous papers. So we can see that autonomous auto response is not there in any paper, and we have reduced the false positive rate to 1.90%, and we have reduced mean time detection from 45 days to less than 1 second, and achieve highest accuracy for 97.63%. So like done. In conclusion is like we have developed and seen an LSTM model for accurate detection and implemented a deep neural network for autonomous response selection. And we have achieved 97.63 detection accuracy, proposed a complete end-to-end intelligent cyber threat hunting framework. Thank you, sir.
Okay. Let me show the previous slide. Previous one. Okay. So you have used the technique LSTM plus I think CNN that we use now
Yes, sir.
for the cyber threat detection. So here you have mentioned different methods. These methods also using the same techniques or different techniques? Because you have mentioned just I think author's title, right? But method's name is not there.
No, sir. It's different methods, not that method only.
Can you tell me the Vinay Kumar and all authors 2019 which methods they have used? There
Sir,
is
they have used
uh,
sir, they have used different methods. Like someone have used random forest, someone have used SVM, and someone has also used CNN plus LSTM also. Like different
so
methods there.
okay. So what are the method that were used in your proposed work? So earlier work that method is not used by any author,
No, sir. Like it's not used by anyone.
not
CNN,
used.
yeah, CNN plus LSTM. Either it can be used, but like DQ and agent. The main our project was specified for DQ and agent building in cyber health environment. It
That
is
is
not.
fine.
Yeah.
That's why I'm asking because your project is split into two parts, threat
Yeah.
detection and response, right?
Yeah.
For the autonomous response, you are going to use a reinforcement learning, right?
Yes. Yes.
Yeah. That's why I'm asking ki, whether that methods earlier yeah, by any author used or not, right?
Yes.
So,
Okay.
okay. Then tell me. Actually, how the queue network that optimize the response actions means how you can say that key it takes less time, minimum time to response, and what is the impact on then false positives and response time?
So like why deep queue networks take less response time? So it is an reinforcement specifically. It is built for that only for high computational to identify high computational patterns and learn for that only. It is a reinforcement learning algorithm.
Okay, thank you, sir.
Okay.
Thank you so much for that presentation. Up next is Nida Saifi with the paper title Applications, Difficulties, and Prospects of Generative Artificial Intelligence in Healthcare. Dear presenter, you may start presenting.
Just give. Hello everyone, I'm Nida Saifi, and I'm an MTech student from ABS Engineering College. And my topic is application difficulties and prospects of generative AI in healthcare, and mm, under the supervision of Dr. Ali Kumar Dubey. So basic introduction is generative AI, which enable machines to generate human-like text, images, audio, and code. So there are various GI models that include GPT-4, ChatGPT, DALL-E, Medcom, and BioGPT. They are having various purposes model in healthcare. The GI is transforming in the fields like clinical documentation, medical imaging, drug discovery, patient care, clinical decision support. So I have reviewed these, and this review explored the application and challenges and the future prospect of generative AI in healthcare. So let's move ahead. So the methodology behind this is research approach. So I have done it in a systematic literature review, and the database includes IEEE Explores, Springer Link, Science Direct, PubMed, and Google Scholar. And the keywords which I have which I have tried to make more studies in the field, like generative AI, healthcare, large language model, medical imaging, drug discovery, clinical decision support. And the study period is the I have done the publication in the from 2023 to 2026, and the strict criteria is peer reviewed, conference paper, and review articles. So there are basically 15 selected papers that were categorized based on application, AI techniques, and benefits, limitation, and future opportunities. Yeah. So there are various applications of generative and healthcare, which is clinical documentation. As we can see in the advanced clinical documentation, there is an option of to automate SOAP notes and discharge summaries, and SOAP notes in the format like subjective, objective, assessment, and plan. Medical imaging, that is AI assisted analysis of CT scan and MRI and X-rays as well. So in there is it is also an application of drug discovery, because it can help you to structure molecular data and design molecular data, and drug generation is also there, and the personalized patient care is also. So customer treatment recommendation it will provide you, and medical chatbots. So it does help in doing patient education and virtual assistance. There is also a field like medical education and research, which is content summarization and clinical training. So the challenges and limitations are hallucination and inaccurate medical information. As we understand the term, the word hallucination is hallucination is like providing the data which seems to be as true, but it is not. It is not seems to be as factual. It is like a fabricated true, and it provides an inaccurate result. So these basically are the challenges. And the patient privacy and data security concern, as there is an ethical concern, because the healthcare the patient's data is quite sensitive in healthcare, and we need to take care of it. Like it should have the security concern and privacy of the user and their respective data. There is biasness in training data, leading to their unfair outcomes. Like biasness, what basically biasness is when what basically biasness is when you when you train a data and when you train when you train a certain population, and the data is also based on historical data, so AI may produce inaccurate or the result which is not correct, or it which is not under represented group. So it will lead it to biasness in training data, and to which leads you to unfair outcomes. Difficulty integrating with existing electronic health record system. So there is also difficulty in integrating with EHR. So so this is a future scope for EHR. There is a model which can be done, which can be deployed. So we can integrate it with EHR, so that it will lead you to the more enhanced and most transparent and trustworthy models for in the terms of accuracy. And if there is a limited and there is also limited explainability and transparency of AI decision. And the fifth one is ethical and regulatory challenges in clinical deployment. The development of healthcare specific large language model is there. So integration with EHR, as I've already told you, and the explainable AI for transparent decision making. And also explainable AI tells the doctors how to respond, why AI has provided you the recommendation, and lets you to understand what kind of recommendation it has make you to understand. And multimodal AI combining text, medical images, and patient records. Stronger privacy, security, and ethical governance. So there is also a human loop validation for safe clinical deployment. It doesn't matter if the data is from the data is generated by an AI or the human. It should be reviewed from clinical clinician supervision to understand what basically if there is not any hallucinated or a biasness in data or like any inaccuracy, so it should be reviewed by a clinical supervision to move further. That's it. Hello.
Okay. As you know that there are so many challenges use of GenAI in healthcare, right? And
Sir.
which challenge you feel that it is the biggest challenge while adopting GenAI in healthcare, like accuracy, explainability, privacy, or regulatory compliance, and why?
Okay.
Which challenges you feel it is the biggest one while adopting the GenAI in healthcare? Hmm? So which one is that and why?
uh, it is explainability or interpretability, I must say, and because in healthcare, doctor needs to know why an AI system has given a particular diagnosis, or we can say recommendation. So there are many generative AI model, especially deep learning, act like a black box. So they may they may provide you an output without clearly explaining how they reach that conclusion. So it's like a biggest challenge, and there may be a hallucination in it.
Okay, and just let me know which healthcare application of GenAI has the greatest potential for the real world impact.
Which application?
Yeah, GenAI, because GenAI used in many healthcare application. Is there any specific healthcare application which has the greatest potential for the real world impact? Do you have
So,
study different healthcare applications where the GenAI is used?
in CT scan, MRI scan, X-rays, like this.
Uh,
Okay. So medical imaging, I must say, because in medical images we can see MedPalm, which can provide you the image based on the text you provided, the text prompt you provided, and if you it can analyze CT scan and MRI scan, X-rays, ultrasound to detect diseases.
okay. Thank you, madam.
Thank you, sir.
Thank you so much. You can stop presenting your screen. Okay. Next, we have Rutuja Jogas with the paper titled Design and Implementation of a Cloud Lab Monitoring and Predictive Alert System using AWS and Machine Learning. Dear presenter, you may start presenting. Next, we have Parag Balachandra with the paper titled Designing Next Generation Dashboards and Formulation of Mathematical Litmus Test Model for its Performance, Governance, and Intelligence. Dear presenter, you may start presenting.
Good afternoon, madam. I have just requested you to share my screen.
Yes, you can present now.
So I hope I am audible and screen is shared and that is right in front of you. Hello.
Yes, sir.
Yeah. So good afternoon, one and all.
Sir,
I am
the presentation hasn't started yet.
so shall I start? Hello.
Yes, sir, you can start your presentation.
Now things are visible.
We can't see the presentation.
Yeah, might be problem with bandwidth. So wait for a second. Hello.
Yes, sir.
Now can you see the screen?
We can see the screen, but we can
Yeah.
only see a
Uh,
folder. We cannot see the presentation yet.
now.
No, sir. Yes, sir, it's visible now.
Okay. So I am Dr. Parag Bhalchandra. Good afternoon, one and all. And I'm going to present my research paper, Designing Next Generation Dashboard and Formulation of Mathematical Litmus Test Model for its Performance, Governor, and Intelligence. Actually, dashboard is something that is related with ICT reforms. And we know ICT has emerged as one of the crucial ingredient almost in all disciplines. So in government also ICT plays a role. But what we observe is the dashboards, they are static dashboards. And when we underwent literature review, we understood that dashboards are thought in terms of usability and visual designs only, whereas no attempts have been made to understand or characterize their performance and optimality function as such. So we understood that the correlation between designing dashboard and its usability for a domain, it seems missing. Further, the mathematical test using which we can weigh the performance of the dashboard is also not extensively came so far. So see, because we don't have much time there, I will skip some of the slides and we'll go to research objectives. So assuming this is the scope where we can possibly invest into dashboard theory, we hypothesize that can we redefine dashboard as an intelligent analytical system rather than a static visualization interfaces, because nowadays dashboards are more to the visualization sides rather than the analytical intelligence as such. Then we also thought, can we establish a scientific framework capable of mathematically evaluating a dashboard performance under different operational environment and address it by coming with a 21st century dashboard model? Because AI has came all the way, and it has evolved as a separate discipline. So we also need to think, can we integrate existing dashboards with the AI so that whatever we hypothesize as intelligent analytical system that can take a shape? And if it is yes, how its architecture could be? Then we thought, can we transform dashboard engineering into measurable optimization problem? This is some sort of mathematics, and provide objective criteria for comparing alternative designs as such. So the moral of the story is we came with developing a next generation dashboard architecture Then we came with a mathematical optimization model, and then we came with a dashboard suitability litmus test uh, during the course of our research paper as such. Now, this is what the proposed architecture is. So we propose a three-dimensional 21st century real-time intelligent dashboard architecture, which has 7 layers. This architecture is not a conventional stack like which we study in OSISO model or TCP model, but it is like that, but it is living continuously evolving ecosystem. Here, a height dimension represents actionable insights. One can go from raw data to actionable insights. The breadth dimension represents times and real-time data flow. And the depth dimensional represents domain diversity, because we are of the view that one dashboard design would not be recommended for almost all domains. So if domain change, characterization of dashboard would also change. To summarize the layers include data source, ingestion and integration, processing and streaming, storage management, AI and analytics, visualization and interaction, decision and action. Decision and action as such. Now we observe that our 3D model can act as a actionable point where national digital infrastructure sector policy and local decision coverage could be incorporated using that. And one example we can address is the example of the NEP 2020 policy. NEP 2020 itself is a paradigm shift in higher education or educational sector, and it has emphasized multidisciplinary learning, flexibility, quality improvement, and better institutional outcomes. Unfortunately, if we try to measure all these, say, verticals in the NEP, conventional annual compliance won't work. And this is the place where we can go for a dashboard design. And we think like, because it has so many performance indicators as such, this aspect could easily be mapped to our three-dimensional model as such. Then the mere proposal of one three-dimensional architecture was not our motto. We were more interested in mathematical optimization, because initially we thought there is no correlation between the dashboard design and the domain as such. And in order to say yes or no to that, we need to dig out the mathematical optimization as such. So we had some assumption while writing this, while doing this study and coming with this research paper. Our contribution is to show that dashboard success requires more than user interface. So mere visualization qualities will not call some dashboard as good or bad. So we need to come with some aspects like we can do. So in order to do mathematical optimization, we can the mathematical optimization is not possible. We cannot do it without mathematical aware pipeline and infrastructure decision, as many digital dashboards are represent symbolic rather than operational. We cannot do it unless we have qualitative and quantitative insights, because mere visual effects won't help us. We cannot do it unless we do analysis of dashboard engineering trade-off, because dashboard is understood by means of some parameters like response time, throughput, data fairness, infrastructure cost. So we need to weigh like what happens if one parameter takes a high value, other takes a low value. That trade-off we also need to have with us. Otherwise, mathematical optimization is not possible. Then we also need to do a correlation analysis, as I told earlier. So with this view, we understood that that dashboard design cannot rely solely on the intuition of the designer. Instead, it must be represented by means of mathematical optimization model as such. And this is the need. We try to characterize the dashboard performance model and dashboard performance optimization model as such. So we have defined dashboard performance in terms of a function. So dashboard performance is a function of L, T, F, C, CO, and S, where L is the latency, T is the throughput, F is the freshness, C is the consistency, CO is the infrastructure cost, and S is the security governance compliance as such. And then we added some weights like alpha, beta, gamma, according to organization priorities, because some dashboard of some organization may expect less latency but good throughput. The freshness rate is also high, consistency is also moderate. Likewise, if we go on changing the weights, um, what happens, that is being summarized in next slide. So we have two functions, the dashboard performance functions, and how to maximize the dashboard performance with respect to weights like this. So when we say escalated some domains like government and other, so we find these weights may differ by domain, as say in case of government settings, weights may differ by domain, as emergency response system may align high consideration to latency and freshness, while archival oversight system may assign greater importance to consistency and cost. So other domain may consider reciprocal of the latency, because latency is the inverse of the throughput. And if we try to understand latency, we can definitely understand how to scale our workload as such. So that's why the equation number 1 and 2 help us to understand how much latency reduction is worth a given increase in cloud spending, how much consistency improvement is gained by moving from periodic extract, transfer, and load or batch job. Uh, when does improved freshness justify additional security investment as such? So these questions are definitely questions of optimization, and that's why the dashboard performance could be expressed as a optimization model as such. And this is the model what we have proposed. Now using equation 3, we have added a parameter called as operational risk here. So we have other parameters like latency, throughput, which I just explored. By adding operational risk parameter and then by adjusting the weights, the alpha, beta, gamma in this equation, we can have exemplification of some things. Like in a disaster management dashboard, latency and freshness must receive very high weight, because even a delay of few seconds may affect life-saving decisions. So while designing dashboards for disaster management, the designer must keep into mind these two facts, that that more consideration should be given to latency and freshness as such. In case of university academic dashboard, latency may not be very critical, but consistency, interpretability, fairness, and long-term trend accuracy becomes more important. Similarly, in a banking fraud dashboard, latency, security, and anomaly detection accuracy become the major factor as such. So, using
Dear presenter,
hello, madam.
I'm sorry to interrupt, but you have crossed the 9-minute mark. Conclude your presentation soon, please.
So with this dashboard objective function, we try to frame something called as dashboard suitability litmus score. And depending upon the value of dashboard suitability litmus score, we try to understand which dashboard type is suitable for which domain as such. And this we try to justify by taking some examples, like example of a traffic dashboard. Here our litmus model suggests that the traffic dashboard must prioritize speed, scalability, awareness, even if other factors like auditability and fairness are less emphasized as. So because we are running out of time, I just skip some of these slides as such, and I come to proper conclusion as such. So we have tried to come with a theory to characterize dashboard as such, and this work present a comparative framework for next generation of intelligent dashboard by integrating real-time analytics, artificial intelligence, cloud computing, and mathematical optimization into a unified engineering model. Then we propose mathematical test and dashboard suitability litmus test framework as a means of formal mechanism for evaluating dashboard suitability across diverse application domains, thereby transforming dashboard design from a subjective activity into a measurable scientific process. The key takeaway includes dashboard engineering must move beyond visualization. Optimization provides objective performance evaluation. MLTM introduces a scientific dashboard evaluation framework, and dashboard suitability litmus test enables domain-aware deployment across diverse applications. So these were some of the references which we surveyed while coming with this research paper as such. Now, thank you very much, and I am open for questions.
Yes, it was a nice presentation with different topics that you came up with. I would like to ask you, sir, you are going to design, develop for intelligent dashboard, right? So, what AI, artificial intelligence techniques that were used for the developing such an intelligent dashboard?
Sir, I haven't started with actual designing process as such. Say
Okay,
you are a teacher, I am also a teacher. So
right.
last year I taught UI UX, and I found that they play prime role in dashboard designing. So that caught my attention, dashboard
Okay,
as a subject. And then I say went into the world of the dashboards and found that they are more or less like visualization tools as such. And the artificial intelligence has came in picture. So my concern was how to scale conventional dashboard to AI based dashboard as such. This was my first concern, which I addressed in this paper.
okay.
Second,
Yes, yes. Please
sorry.
continue.
Second observation I found that a conventional dashboard design would not be appropriate for all types of domain as such. Like you have a WordPress website for your credentials. I may too have. And because we are from academics, whatever model you have used will not be justifiable for mine website because my credential sometimes changes, though we share the same sphere as academician as such. So I thought like healthcare data dashboard, say traffic control dashboards, maybe a dashboard showing sales and revenue as such, they must not follow same model. There must be change in the model, and in order to understand that I came with mathematics, because if we express something mathematically, then only we can understand what is changing and what is not changing as.
Right,
So
right,
these
right.
two efforts I made in this paper, sir. Naturally,
Yes.
next step will be to come with an actual dashboard where AI integration and real-time analytics would be seen. Hello? Hello?
Just wait, sir.
Please.
Hello. Sir.
Sir.
So it is not implemented yet, right?
Yeah,
So
right.
yeah. So my suggestion would be like this: ki yes, this is good concept. Ki you come up with the intelligent dashboard. So try to find out what AI techniques would be used to
Right.
make it more intelligent, and
Sure, sir.
try to test that dashboard across the various domain. You
Right,
already
sir.
told traffic, health, and all. So
Right,
that
sir.
how it could be how it could be become a generalized one,
Right, sir.
right?
Right, sir. Right,
So
sir.
that yes, these things yes you will be consider and you can go with this concept, right?
Thank you, sir. Sure.
Thank you, sir.
Thank you, sir. Thank you, one and all. Thank you.
Thank you so much. Next, we have Rini Day with the paper title Redesigning Indian Education with Personalized AI Immersive Learning for Cognitive and Engagement Enhancement. Dear presenter, you may start presenting.
Thank you so much. I will just start sharing my screen, just a moment. Hope my screen and my voice is also audible. My screen is visible.
Yes, ma'am.
Okay, thank you so much. Good evening to one and all present here. We started in the afternoon and it has gone in the evening. It was wonderful hearing to all of you. I am here to present my paper on redesigning Indian education with personalized AI immersive learning. Artificial intelligence, AI, is rapidly transforming various sectors, with education being one of the most promising fields for AI integration. AI systems monitor performance, pinpoint gaps in learning, and suggest focused learning materials, enhancing the learning rate and minimizing the reliance on a set teaching speed. So, what is the problem? In India, various structural limits influence the learning outcome, such as large teacher-student ratio, focus on rote learning, low individual attention, and unavailability of teaching resources that are context-specific. Government and rural schools are more faced with these challenges as they have limited infrastructure, and there's also a lack of trained educators. Current reports, such as those of the Annual Status of Education Report, ASER, are no different. And we know that most students cannot read basic English or even do basic arithmetic, which moreover underscores the requirement of new ways of working. So how can the gaps be filled? The gaps can be filled with the use of AI-based systems combining real-time adoption, AI algorithms with environments that capture attention, such as VR. Students can see and interact with VR. Students can see and interact with complex concepts visually, tactically, and cognitively, obtaining a practical application of the material. Early pilots in India, including the AI for Schools project under CBSE 26 and integrations like Microsoft's Immersive Reader, have shown improved reading comprehension and inclusive learning for children with special learning needs. Now, studies at IIT Bombay 2021 explored VR-based science modules, revealing improved curiosity, problem-solving skills, and academic performance in experimental groups compared to the controlled ones. Moreover, edtech startups like Byju's have begun incorporating 3D, there's Byju's, there's Vedantu, and a number of other edtech setups which are incorporating 3D immersive modules with AI-powered learning analytics and have showed promising results in the urban settings. The NEP, the 2020, has a high level of focus on the attainment of foundational literacy and numeracy in 2025, as well as the objectives of holistic learning and cognitive development that are directly in line with the capabilities of immersive learning systems. Immersive systems powered by AI can visualize abstract concepts and at the same time analyze the behavior of the learner to assist them in real-time adaptation, formative assessments, and intelligent tutoring. This strategy encourages the movement towards standardized teachings and learning to customize and interactive learning that suits the needs of individual learners. The growing body of evidence suggests that immersive learning using AI is effective in improving learning outcomes under any environment. As an example, to study mathematics in China, Chen and al. 2022 study designed an AI VR system and discovered the accuracy of the problem solving increased significantly. In addition to also motivating the students towards this. McCrancy and al. In 2020 recorded a greater cognitive presence in immersive VR learning as compared to desktop learning in Danish Indian schools students. The comparative results of the selected world studies assessing the AI incorporated immersive learning in Indian education are summarized in this slide. Due to the shortage in time, I'm just quickly going through all of these. Studies on immersive learning in India are still immature. Students in the IIT Bombay study 2021 with VR-based science modules report showed considerable improvements in conceptual clarity and interest in science. Likewise, Sharma et al. In 2022 incorporated AI-driven immersive reading tools of English in schools in Delhi and found the tools to be associated with improvement in reading comprehension and vocabulary acquisition. The majority of the Indian schools are pilot projects that have small sample size and which are not rigorous experimental designs or cognitive process evaluation. The slides provides like a summary of what includes in the Indian research perspective. My research framework is structured into four. One, it was a system architecture which defines how modules and data relate to each other. AI adaptation model, which is supported by mathematical formulation and proves to make sure it is reliable and accurate. And three, immersive environment design modules, which explain the structure and interaction mechanisms in the virtual learning spaces. And four, experimental procedures, which describe the approach used to evaluate system efficacy through empirical validation. My study involved 200 students from 4 Indian schools, urban and rural settings. Participants were randomly assigned to experimental A, immersive learning, and the controlled traditional learning groups. The procedure that we used was like a pre-test, like a baseline cognitive assessment. Then the intervention was like a 4-week immersive AI-based module covering some math and science topics. Again, post-test, we did an assessment of cognitive gains, engagement recoding during sessions using AI analytics embedded within modules. The null hypothesis which we used for this was no significant difference in cognitive gains between the groups, and the experimental hypothesis was the experimental groups exhibited higher cognitive gains. Now, building upon the literature and the methodology, this study introduced a novel AI-driven adaptive immersive learning framework called Cogni AI VR, designed to optimize cognitive gains and engagement among Indian students. The proposed system integrates 3 innovative algorithms: adaptive Bayesian knowledge tracing with reinforcement learning. This algorithm learns a model of the learner's knowledge and adapts to the difficulty online. The second was the graph-based immersive path optimization, GIPO algorithm, which creates immersive learning paths tailored to reduce the cognitive load, thus keeping the teaching and learning experiences both effective and feasible. And the third one was the engagement aware dynamic content selection, the EADCS technique, dynamically selects the sections of the content to be delivered to the learner that engages in a pursuit of maximum learner engagement. And so all these 3 algorithms contribute uniquely. The first one, which was the ABKT-RL, ensures optimal adaptation based on learning state and rewards. The GPIO constructs immersive module navigation effectively, and the engagement module, they dynamically selects content and then minimizes cognitive and emotional engagement. As mentioned in the methodology, to measure cognitive improvement, standardized pre and post tests were administered for mathematics and science modules. We calculated the NLG, which was normalized learning gain, for the experimental Cogni AI VR and the controlled traditional instruction schools, which showed significant difference in cognitive benefits as seen on the screen. In contrast, learning outcomes improved significantly in the experimental groups using an immersive learning tool, the Cogni AI VR powered by AI. The average NLG for the experimental groups was 0.49, which was significantly higher than that of the control group of 0.14. NLG is the evidence of cognitive development, which has shown the impact of Cogni AI VR on promoting deeper learning. Engagement was analyzed across 3 dimensions: behavioral, emotional, and cognitive. All these 3 types of engagement were significantly better in the experimental groups that use the Cogni AI as compared to the conventional AR. All three Cogni AI VR algorithms were tested for correctness, speed, and enhancement over their baselines. The performance of the 3 algorithms integrated within the Cogni AI VR system demonstrated significant improvements in the key matrix. ABKT-RL, which enhances adaptive learning, achieved an accuracy of 92.4%, which is a substantial increase of 14.3 over the baseline of 78.1. This improvement demonstrated the system's ability to dynamically adjust the learning content to better match the individual students' needs. in this slide, we can see that it shows the performance of our proposed Cogni AI VR system. The ABKTRL personalizes learning that has achieved 92.4 accuracy. GPIO finds the best learning path, making learning 22.7% more efficient. The engagement-aware dynamic content selection selects the most engaging content and achieved a prediction ratio of R squared to 0.84. Now, these compared to Byju's, Practically, and IITB VR, our proposed system achieves a highest normalized learning gain of 0.49 and highest learning accuracy of 92.4%, demonstrating a better personalized learning performance. In terms of system efficacy, which was evaluated to assess the deployment feasibility in resource-constrained schools, there was a significant increase in efficiency compared to current AI VR systems. The suggested structure shortens the average processing time by 12%, as it is lowered to 1.31 seconds compared to 1.49 seconds, which is there. Now, this minimization helps to accelerate system reaction and a more seamless user interaction while learning. Better efficiency promotes broader use, especially in systems with little computing abilities. These findings show that the system does not reduce the performance and minimize resource use, which fortifies its viability to be implemented in resource-limited educational environments. And this paper includes Cogni AI VR and AI-based immersive learning model, which is created to tackle the continuing issues of Indian education, such as poor conceptual knowledge, lack of interaction, or no adaptive pedagogy. Findings indicate a significant positive change in learning outcomes. And there was an increase in, of course, we did mention that there was an increase on behavioral, emotional, and cognitive levels as well. It also promotes the alignment of policies with NEP 2020 by implementing evidence-based policies. However, the limitations that we find over in this are that the duration of the intervention was only 4 weeks. We did not conduct any long-term retention analysis. There would be some institutional coverages, and the other thing is that it relies on a VR hardware, which can limit its scale in resource-constrained environments. And that's about it. Thank you for your patience, and I'm open to questions if any.
Okay, madam. I just want to ask you, do you have considered the samples from diverse background, like do you have considered their educational background? Do you have considered whether the students from rural or the urban areas or the two-tier city, three-tier city, right? Or
Yes.
metro cities, right? So do you have considered that? Do you have considered those students and their metrics while during such while you implementing these Cogni AR/VR methods?
Yes, sir.
Okay. Do you have analysis of rural and urban students?
Yes, sir.
How
We had
actually?
done separate analysis of from all the 4 schools that we had covered.
Okay. That was important because when you consider how much it is improved over the
Yes.
traditional teaching pedagogies, so it is very important to consider.
Yeah, yes, sir, absolutely. And while we were doing it also, we found that while it was kind of a little easier and kind of very familiar to the urban setting people. For the rural schools that we were doing, we were extremely excited when we were doing these experiments. So yes, there was a lot of difference in engagement and the acceptability factor as well while we were doing this.
Okay, thank you, madam.
Okay, thank you.
Thank you so much.
Next, we have Manoj G. Manawar with the paper title Smart Last Mile Delivery Failure Reduction Using Predictive Analytics and Intelligent Route Optimization. Dear presenter, you may start presenting.
Yeah, is my screen visible?
Not yet, sir.
I guess it's visible now.
Yes, sir, it's visible.
Okay. Good afternoon, respected session chairs, distinguished reviewers, and fellow researchers. I'm Mano Sandingamano from Department of Computer Science Engineering at Dayanand Sagar University. Today, it's my privilege to present our research titled Smart Last Mile Delivery Failure Reduction Using Predictive Analytics and Intelligent Route Optimization. Our work explores how artificial intelligence can transform one of the most expensive and unpredictable stage of logistics by predicting delivery failures before they occur and recommending intelligent operational decisions. Last mile delivery is widely recognized as the most expensive and most operationally challenging stage of logistic process. Despite significant advances in the transportation technologies, delivery failures remain common. Factors such as inaccurate addressing, heavy traffic, customer unavailability, and inefficient routing continue to affect delivery performance. Studies indicate that nearly 15 to 25% of first attempt delivery fail, leading to increased transportation cost, reverse logistics, delayed deliveries, and reduced customer satisfaction. Existing logistics platforms mainly react after a delivery problem occurs. Our research addresses a different question here. Can we predict these failures before dispatch and prevent them proactively? Although modern logistics systems provide route planning, tracking, and delivery time estimations, they still operate as isolated systems solutions, and they rarely predict whether a delivery is likely to fail. More importantly, they do not recommend the prevention actions or elevate the effectiveness of those actions before implementing. Our objective was therefore to develop an integrated AI framework capable of predicting delivery failures, optimizing routes, recommending interventions, and simulating operational outcomes with a single intelligent platform. In simple terms, our framework follows three principles: predict, optimize, and improve. Yeah, this slide presents the overall architecture of our purposed smart delivery intelligence framework. The workflow begins when a customer places an order. In the first stage, the system performs address passing, geocoding validation, and feature engineering. These features are then processed by XGBoost machine learning model, which predicts the probability of delivery failures before dispatch. Once the delivery is identified, the framework enters the optimization stage. Here, a self healing place graph continuously learns from the historical delivery experiences and then improves routing decisions. Next, the system performs counterfactual analysis, evaluating different operational actions such as customer precalls or delivery rescheduling to determine most effective interventions. Finally, a digital twin simulation estimates the operational impact of these decisions before they are implemented in the real world. Rather than in reacting to delivery failures after they occur, our framework enables logistic companies to predict, optimize, recommend, and continuously improve delivery operations through intelligent decision making. Yeah, after validating the delivery addresses, the system extracts several meaningful features that influences delivery success. These includes address confidence, geographical confidence, delivery distance, historical failures, area risk, and temporal features such as a delivery time. These features are then provided to the XGBoost classifier, which predicts the probability of delivery failure before the package is dispatched. We selected XGBoost because it offers excellent performance on structured logistic data, provides faster inference, and delivers high predictive accuracy. Instead of relying solely on distance-based routing, our framework makes intelligent decision under delivery risk prediction. Coming to the slide, we evaluated our framework using test data sets and obtained encouraging results. The XGBoost model achieved 82% precision and 80% recall and 82% F1 score, and ROC of 88%, indicating a strong predictive performance. Importance analysis showed that the address confidence was the most influential factor, followed by geographical confidence and historical delivery failures. In terms of operational efficiencies, our intelligent routing strategy reduces the delivery that is travel distance from 24.3 kilometers to 17.4 kilometers, representing a 28% of reduction. Furthermore, the digital twin simulation demonstrated a decrease in failed deliveries from 45 to 28, corresponding to 37.8% of improvement overall. The framework has potential to reduce delivery failures by approximately 20 to 30% while improving overall logistic efficiency. The uniqueness of our research lies not only in predicting delivery failures but also in recommending intelligent operational decisions. The self healing place graph enables the system to learn continuously from previous delivery experiences. Counterfactual analysis helps determine the best intervention before dispatch, while digital twin simulation estimates the impact of these interventions before they are implemented. Together, these capabilities transforms the traditional logistics into intelligent data-driven ecosystem that reduces costs and improves customer satisfaction. In conclusion, our proposed smart last mile delivery intelligence framework combines artificial intelligence, predictive analysis, and intelligent route optimization into a unified support system by predicting delivery failures before dispatch, optimizing routes using historical knowledge, and recommending proactive interventions. The framework significantly improves operational efficiency and customer satisfaction. We believe this approach has strong potential in development, real world development in modern logistic networks, and can serve a foundation for future AI driven delivery systems. And thank you very much for the time and attention. I would be happy to answer any questions.
Okay. Okay, Manu sir, I just want to ask you, how did you perform digital twin simulation? Can you elaborate in the architecture that we have?
Okay,
Yeah, I'm
sir.
audible.
First, we created a virtual model of the delivery network using historical delivery data. Previous delivery data, the of that place, historical data, and then we then simulated different scenarios such as route optimization, customer pre-calls, delivery rescheduling, and compared key metrics that they like failed deliveries and total travel distance before and after the intervention. This helps to estimate the operational impact before real world implementation. Like before delivering a particular product, we are just predicting using this digital twin.
Okay, so do you compare your model with any existing models?
Yeah, in this works, we evaluated our proposed XGBoost based framework independently, not into a perform or a direct comparison with any other models, such as random forest and SVMs. Comparing these multiple models is a part of future works. And now, as if I have not compared with any other models, because XGBoost always produces a uh, excellent prediction based on the structured data set which you have given.
Because you mentioned in your proposed framework AI-based failure prediction, right? So, which algorithms you have been considered for the failure predictions? Because under the AI, there are so many algorithms for the failure prediction, right? For the prediction purpose.
Yes, sir. For failure of prediction, we used the logistic regression and random forest and
Okay.
XGBoost also. We selected the XGBoost because it performs well on structured tabular data, handles feature interactions efficiently, is a robust missing value. If there are any missing values, it handles very quicker than all the random forest as well as the logistic regression. And it also provides high prediction accuracy, and it offers the fast interference suitable for real time.
Okay. Thank you, sir.
Thank you, sir.
Thank you so much. Now I would like to call Namo Panchal.
How many are remain, madam?
There's one more after this, sir.
Okay.
Hello.
Yes, sir.
Hello. Am I audible?
Yes.
Okay. Due to some reason, Namo is not available. So I am the co-author, Himanshu Bhatt. I'll give the presentation today.
Okay, yeah.
Good morning, everyone. Our paper is basically Site Seeker, Intelligent Block Discovery through Semantic Interpretation. The goal of this project is to improve how people discover useful technical blocks instead of relying only on keywords like traditional search engines. Our system understands the meaning behind the user's query using AI and NLP to provide more relevant results. The problem here was the internet consists millions of blogs, making it difficult to find the high quality information. So traditional search engines mainly match keywords. Because of this, users often receive irrelevant or low value of results even if the keyword are correct. This creates an information overload and wastes the times, especially for the developers and the researchers searching for technical content. Uh, So these existing systems have three major limitations. First, they don't understand the actual intent of the user search. Second, many modern websites use JavaScript, making them difficult for traditional crawlers. Third, existing semantic search is mostly available for academic papers and not for the general technical blogs. This gap basically motivated us to build the site seeker. Just a second. Yeah. Basically, then SiteSeeker automatically searches the web, extracts the blogs, understand the context using AI, and rank them based on their relevance. Instead of checking whether keyword matches, it compares the meaning of the user's query with the article. It also filters duplicate and irrelevant content, making it easier for the user to find useful blogs quickly. This was our proposed solution. After that, our system has basically three layers. The front end is built using Next.js and Tailwind CSS, providing a simple chat-based interface. The backend uses Node.js and Express to manage APIs, requests, and caching. Finally, the intelligence layer performs web crawling and semantic analysis used AI models to rank articles according to the relevance. The hybrid crawling basically the different website requires extraction methods. So we use Scrappy for static websites, Beautiful Soap to clean the HTML and Tailwind API for JavaScript with the heavy websites. Combining these three methods, it allows us to collect the data from a wide variety of websites efficiently. After collecting the articles, both the user's query and each blogs are converted into vector embeddings using transformer models. We then calculate the quotient similarity to measure how closely the meanings match. The final ranking uses 70% of semantic similarity, 20% of content quality, and 10% of information freshness. This ensures that the meaningful and updated articles appears first. Results where that our experiment showed semantic relevance score above 0.90 for highly relevant articles. Articles scoring below 0.65 were filtered out as irrelevant. The average response time for the system was only 0.68 seconds, demonstrating both high accuracy and fast performance. After that, in conclusion, the site seeker combines intelligent and crawling with a transformer based to improve discovery. It understands user intent, filters, and relevant content and delivers the best search result than traditional keywords based method. In the future, we are going to add multiple embedding models, automatic content summarization, and real time trend detection. Thank you.
Okay, for the similarity to find out the similarity index, you use the cosine, right? Cosine similarity index. So
Yes.
only one is used, or other are also used, and then you have finalized the cosine. So
No,
what?
total top five are used for the cosine. From that top five, whichever is 0.98 or 0.9, we first rank them as number one, and after that till 0.65, we rank all the if there are five total blocks, then we will like rank five blocks. If there are six and the last one is 0.65 or below 0.65, then we don't like we don't rank them. We just make it as irrelevant.
Okay, thank you, sir.
Thank you.
Thank you so much for that presentation. With that, we are done with all our presentations for today. I would sincerely like to thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you all for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I would also like to thank our session chair, Dr. Sopan. Thank you for chairing this session. And as a token of appreciation, on the behalf of team of ICT4SD 2026 and Global Knowledge Research Foundation and partners, please share with us any closing remarks if you have any.
Yes, ma'am. Yeah, thank you. Thank you to all the presenters for sharing your valuable research. And the quality of the presentation was really good, and exchanging of your ideas that have been made this session is more and more informative and engaging. So I wish you all the continued success, and thank you, the conference organizers, for giving me the opportunity as a session chair. Thank you once again.
Thank you. Just can everyone turn on their cameras for a quick virtual snapshot? Thank you everyone for your valuable presence today. Take care and stay safe. Thank you.